term in Sanskrit is anurupyena. So according to the split, or according to the operation that you do in each split, you will get the answer in proportion. So doubling can be seen as addition with the same number. These are all facts. Now let us go to some practicum. So where you are asked to double these numbers, they are 2-digit numbers. Of course, these are very easy calculations that you can do in your mind. So this is 24. So in the mind, you should try to figure out what is the operation that needs to be done. You have to split 24 as tens and units place. So you multiply the tens place by 2, multiply the units place by 2. That makes it 48. Similar rule applies here. Actually, I should have put not equal to, it's an implies. So this is 28. This is an easy figure. Here you have to note that 5 multiplied by 2 gives 10. In traditional way of calculating, this would have been a carryover, but in Vedic mathematics, we try to avoid carryovers as much as possible. So this should be 50. So one way of seeing this is 20 times 2 plus you add 2 times 5. This is also direct. We know what is the double of 35. So the double of 36 should be double of 35 plus 2 times 1. This is the fact of proportional. So 72 here, and this should have been 2 is taken away from 50. If you multiplied 50 by 2, it should be 100. So you have to take 4 away while you multiply by 2 or double. So this is 96. So these are all very direct facts. Now we can see a little bit more complicated numbers. So if you want to take double of 68, this exceeds the number 100. So you can split the number into 60 and 8, and you double them separately. So if you double 60, you get 120. If you double 8, you'll get 16. So the total answer should be 136. So we shall give more examples. So we have understood double to be something like addition itself, but you can do it in an easy manner using the sutra of proportionality or anurupyena. Let us take some larger numbers now to play with. What about 273? What is the double of these? So one easiest split that you can think is to double each number. So this is 6. The next one would give 7 into 2 should be 14 and 2 into 2 should be 4. So we can use a simple representation like the fact that we used yesterday. So 4 you can write here. 14 you will represent 4 with a 1 written below. So this is just for beginners to understand. Eventually you can get rid of these notations. So this is going to be 546. This is for beginners to just understand what is exactly going on. We double each digit separately, and we are going to represent the second number if it exceeds 10, and that number you're going to put just as a subscript next to that number. What about 636? We can apply the same rule here. So 12, 6, and 12. The last number you can put as it is. So this is going to be 1272. Let's go with one more example in this practice. So I will put these practice questions in the Practically app. You can solve after this lecture. So let us take this last example. So the double of 707, how do we do? So last number 7 multiplied by 2 is 14, then 0, and then again 14. So this is a useful notation. So this is going to be written as 141. Now we go a little bit ahead. and say, suppose we wanted to multiply the original numbers by 4. How do we do that? So these are very easy things to do once you have doubled. So the first task in any of this case is to double the number. So multiplying by 4 is equivalent to doubling twice. So this is an interesting fact while it comes to larger numbers. So if you want to multiply 273 with 4, you just have to double this number 546. What is that? We'll use the same notation. So first number is going to be 12, written like this. The second number is 8 and the last number is 10. So this is going to be 1092. And in the second case, I have 4 digits to multiply with 2. So 4, 14, 4 and 2. This is going to be 2544. Let's do this last one as well in the practice set. So you have to multiply 707 by 4. Now this can be easily done as follows. You can take the double of the number first and then multiply by 2. This is a direct exercise. 8282. So I hope students are clear with this concept. So let us drive a little bit more examples. So try to multiply this 2-digit number by 4. So the steps you have to do is, this is double of 35. This is a known fact. We know double of 35 is 70. So double of 70 is 140. Now this is faster than the traditional method of multiplying. What is the traditional method? Let us have a look into the traditional method in which you are mostly taught in schools. Traditionally, what you do is you multiply 4 with 5 to get 20, and that 2 is carryover. Then you will get 4 times 3, which is 12. And then you have to add that, which is 140. Now this, by doubling twice, you get the answer very quickly than this traditional method. And you don't have to take the burden of multiplying each number by 4. Now what about multiplying by 8? This is equivalent to doubling thrice. So thrice double this number 26. So this would imply we are going to have 26 multiplied by 2, which is 52, into 4. Now multiplying by 4, we have seen a method. First double the number and then double it again. So 104 multiplied by 2, which is going to be 208. Now let us practice. So I just wanted to emphasize on practice and theory before we see these problems appearing on the screen. So there has to be some balance between what is called as theory and practice. Now, have you seen a bird fly? So the bird has 2 wings. I often compare theory and practice with the 2 wings of the bird. So you should give some kind of equal importance to both theory and practice. Now, why it is so is as simple as this. Suppose the bird, one wing was weak, it would fluctuate to one of the sides. It cannot fly straight. Similarly, for any mathematical concept, if you only know the practical, or if you know how to do, but without the knowledge that is underlying it, it is like you're taking a deviation. You're not able to drive smoothly ahead. So this theory part is somewhat helping you to navigate in a straight direction. So think of the bird who has a lot of practice but does not know the theory behind how it can fly. It is not going to properly use the wings efficiently. So this is why in this kind of lectures, we try to incorporate a little bit of theory, but a lot of practice that helps you create or build the intuition behind the answers that you get. So it is encouraged that you do a lot of practice problems, but take a while to think why it works. That is why the power of observation is to be very much used by the students, especially when it comes to competitive mathematics. So I just wanted to narrate a few incidents where Vedic mathematics played an important role. So while I was doing my engineering, there was a lot of instances where I wanted to complete a set of, say, 100 questions in a limited time, say 90 minutes or so. So each question had to be attempted in less than a minute. So this was possible only because of the Vedic sutras that helped me observe the problems in the right spirit. And mind you, all these problems were worded problems. Worded problems, as we have seen yesterday, are a little bit confusing to tackle because you have to extract the information that is relevant to solve the problem. So this is how the student should gradually move a little bit away from intuitive knowledge that you get from practice to some kind of theoretical knowledge, but always try to keep a balance between theory and practice. So let us try some easy puzzles first. So what you get, 53 times 4. So I'll just do 53 times 2, 106 into 2. This is going to be 212. Let's do one more. 18 times 4. Actually, if you have very good practice, you can do a simple trick. 18 is close to the base 20. So the number should be less than 20 times 4, which is 80. How much less? It should be 8 less because 2 into 4 is 8. So this answer, you can write it directly as 72. What about 22 times 8? Conventionally, what you do is you multiply 8 times 2, 8 times 2 again. So you get 16 and 1 carries over. So the answer should be 176. But here you can use this rule 3 times. So doubling 22 would give 44 into 4, which is again 88 into 2. Here you can use that sutra where completion toward the base would help. 90 times 2 is going to be 180 and you have to take 4 off, which implies this is going to be 176. These sort of numbers have a special place in Vedic mathematics. These are multiplication by 11. So you can convert this multiplication as a multiplication by 11 as 11 into 16. And multiplication by 11 is a very interesting thing to learn in mathematics. 11 is a very special number because it is the same digit 1 which is repeated. So while doing this, one easiest thing to do is to put the number 16 as it is, but separated by one place. And you just have to put the middle number as the sum of the digits of the number that you're multiplying with. So the sum of the digits of 1 and 6 are 7. So you get 11 multiplied by 16, which is equivalent to this problem 22 multiplied by 8 as 176. So we just have used the observation power in order to solve this problem. Let us go to some hard ones. We have already solved for 707 multiplied by 8 or by multiplied by 4 we have already done. So let's do this. The remaining you can take home. So first you multiply by 2, which is 1414 multiplied by 4. This is equivalent to 2 828 multiplied by 2. Now here you can use what is known as the splitting of numbers. Split the number at a convenient place. So the number is going to be 5656. So if you know to double 28, that is just sufficient to find the answer. So this is how you can use your power to observe numbers in order to simplify a lot of calculations. Again, we'll go into doubling some fractional numbers or numbers with decimal places. So this is quite useful when it comes to adding your marks for an examination. Suppose you have got say 2.5 marks for 4 questions. How much you will get? You can do such calculations easily. So 7.5 multiplied by 8. So let us use the doubling technique. You have to use doubling thrice. 7.5 multiplied by 2 is 15 into 4. You again take 30 multiplied by 2, which is going to be 60. A very fun fact. Now let's go for the next question. 2.75 multiplied by 2. How much is that? So 275 multiplied by 2 is what? 550. So 5.5 multiplied by 4. This would again translate to 11 multiplied by 2. This is 22. What about 3.25 multiplied by 4? You can do even the splitting of the decimal and the other numbers. This is very practical when it comes to numbers that does not have carryover. Here we have in fact a carry that is coming due to 0.25. So you have 4 multiplied by 3, which is 12, but 4 multiplied with 0.25 is going to be 1. So the answer is going to be 13. So see how you have essentially reduced the steps and did most of the calculations on your mind. So I'll just take one example from here for you. The others you can take home and solve. 9.5 multiplied by 8. There are two ways in which you can do, at least in the mind. You can multiply 10 with 8, which is 80, and subtract 0.5 multiplied by 8. But 0.5 multiplied by 8 is 4. So how much is this going to be? So 80 minus 4, which is 76. So you can apply these simple tricks to the other problems in the list as well. What about halving? So the reciprocal operation of doubling is going to be halving. So what you have to do is essentially say, but if you are given a number, say n, instead of multiplying, here we have dividing. So what is essentially you can do is the reciprocal operation of doubling. So half of 178. Here we shall encounter this importance of proportionality, the sutra that we just introduced, Anurupyena or proportionality. So 178 is 100 plus 70 plus 8. So let us split this number as 100 plus 70 plus 8. Now halving 178 is equivalent to halving each of these parts. So by 2, by 2, and by 2. So this is going to be 50 plus 35 plus 4. A simple fact indeed, this is going to be 89. Another way of seeing this is also there. That is a lot more simpler. You can write 178 as 180 minus 2. You know how to compute half of 180 because it is a number which is exactly the base, which is going to be 90. So you just take 1 away from 90, you will get half of 178. So there are two methods. Both have used this sutra of Anurupyena or proportionality. Now it depends on how well you can observe a number how well you can see the entire picture. Remind yourself of the story of the elephant. If you go closer to the elephant and touch its parts, you will never be able to guess what an elephant is. You have to step a little bit back, observe to know the number as it is. So this is the small tip that I wanted to convey to the students. Take a step back, think for about 5 seconds. Can you see the whole picture? And then from the whole picture, apply one of the sutras, and then you will be able to speed up your calculation, in spite you giving 5 seconds or 10 seconds for the observation. Now, how you can halve 164? We can split it as 160 plus 4. So half of 160 is going to be 80. Half of 4 is going to be 2. This is going to be 82. 234. Either split this as 200 plus 34, because by this time you will be aware of the half of 34 is 17. So this is going to be 117. Half of 57. This is a number which is odd. This is an odd number, meaning it doesn't have a factor of 2 in it. So 57, if you want to half, you can just take it as 60 minus 3. Half of 60 is 30. 3 by 2 is 1.5. So you just have to subtract 1.5 from 30, which is going to be 28.5. Now here are a few problems for your practice. You have to half the following numbers. I'll just do the last one in this group. Remaining you can take home. What about 456? Let's divide this as 460 minus 4. 460, half of that is 230. So 230 minus half of 4 is 2. This is going to be 228. Now there are some more facts that can go in. This is in relationship with the computer memory. So in computers, you will have seen gigabit memory RAM or gigabit or terabytes of memory to store your data. So what does this mean? So this is a simple set of terms which helps you represent computer memories or even network speeds in some instances. So kilo represents 10 power 3. This will be a revision for some of you. This is 10 power 6. This is going to be 10 power 9, 10 power 12, 10 power 15. Now, there is an equivalent relationship in terms of powers of 2. Kibi is in tandem with kilo. It represents 2 power 10. Maybe is going to be 2 power 20. GB is going to be 2 power 30, and so on and so forth. You can find out what is the power of TB and PB for yourself. So I just wanted to give this facts to connect you how number systems have evolved in this computer age. However, in most of the computers, you will see these terminologies coming: kilo, mega, etc. You won't see kibi, maybe, etc. So this is just an added information for all of you. Let's go a little bit further, how to divide numbers by 4 and 8. So after this, I'll just introduce to a kind of puzzle. After that, I'll take up questions. So how do we divide 72 by 4? You just have to half 72 twice. So 72 divided by 2 is 36. 36 divided by 2 is going to be 18. I urge you to try these practice problems by yourself. Let us jump straight into 104 by 8. Slightly intimidating at the beginning, but there is an easy Vedic method that we have learned where you can divide the number 104 3 times divided by 2. So this is going to be 52 divided by 2. which is going to be how much? 26. So this gives a method to check divisibility by 8 as well. What is the divisibility by 8? Some of you might have learned this already. So to see if a number is divisible by 8, three digits starting from the right has to satisfy the relation that it should be divisible by 8. So we'll talk a little bit more on divisibility in future lectures. So here are a few more practice problems for you to try. So we'll skip a little bit here due to the time limitation and take this up in the next session. So let me jump directly into the puzzle that we have towards the end and leave you for the day to think over that. So we have the main takeaway is that if you apply these sutras, you can forget a lot of traditional technicalities that you have to deal with if you did not know the Vedic mathematics method. So this is the puzzle. I'll just explain it in a minute. So here you will have 6 circles given, and these circles are connected by some lines showing some relationship. You will have to fill in some numbers inside this circle, and the numbers that has to go in each circle are from the set 1, 2, 3 up to 6. A few hints are given how to fill the number in. So for example, the first hint says that each number, if you put a number here and a number here, these numbers in along the line has to add up to 7. The second hint says that the largest number is in the bottom circle. So I'll just, for the sake of this question, put the largest number here, which is 6. 5 is next to 1. 3 is not next to 1. And 4 is in a gray circle. So you have to pick up one of these circles and put 4 into it. So can you all try this puzzle after the lecture? I'll just put up this slide for the puzzle for you to have a look in detail, and I'll put a provision to enter your answer as an objective answer. So try this without fail after the lecture. So I would just like to conclude here and take up some questions. So I can see some raised hands. So Pranamya, you are allowed to unmute yourself.
Sir?
Yeah.
Sir,
Please go ahead.
before page, can you open us, sir?
Sorry.
Sir, before you have been said no, sir, page.
Which page? So you are asking about that divided by 8?
Yes, sir. I does not understand it, sir.
Okay, yeah, sure.
This, sir, table, sir.
Okay.
This,
No,
sir.
so this I have not taken up in this class. The whole idea is that you can forget the multiplication table and just learn your multiplications up to 5. You can do the remaining part of the multiplication. So the whole idea that I put the table is to forget it. You have to unlearn your table, or you need not keep it by heart. That is the whole point. Yeah. So I can see a few more raised hands. So let me unmute Shanmuka. You can unmute yourself and ask.
Sir, I have solved the puzzle which has given by you now, sir.
Okay, that is good. So you'll get an opportunity to write your answer down in the app after this lecture.
Okay, sir.
Yeah. So I think Yashwant, you can unmute yourself. Yashwant. Do you have a question, Yashwant? I think Yeah, Yashwant, you are allowed to ask now. So I can see a raised hand from Sai Surya. Yeah, please go ahead and ask.
Sir, can I have your number?
So currently we have an option to chat in the Practically app. So you can ask any of your doubts through the Practically app. So we are not conducting a one-to-one session as of now, but definitely you can ask your problem either during this question answer session or use the chat facility along with the course. So hope the answer was clear. So this is for all the students participating in this course. You are allowed to ask your doubts in the form of chat so that you will see in the Practically app itself.
One more doubt. Sir, please give us self-unmute option, sir. Do not unmute you.
Yeah, sure. Yeah, so whoever has a doubt can unmute yourself and ask.
Hello, sir.
Yeah, please go ahead.
Every Sunday the class will have, sir.
Yeah, we'll have classes on Saturday as well as Sunday.
Okay, sir.
Yeah.
Sir, which time?
So the time will be the same. So on Sunday it is 10:30. On Saturday it is going to be 6 p.m.
Evening, sir.
It is in the evening. So I'll just put feedback form for all of you to fill in. So this is in Google form. So now you must have received that by chat.
Okay,
So you
sir.
can fill it, the Google form, to give your feedback about the course. So I just want to know from some of you, is the language and the pace of the course, yeah, I'll take up the questions. Let me just complete this. Is the language of the course fine with all of you, or is there somebody who is not very well versed in English and I would like to explain it in some kind of variants? Maybe I can try to give some instructions in the form of Hindi.
Okay.
Yeah.
Sir, Sunday class untada, sir.
Yeah. So the class is going to be on Saturday as well as Sunday. In the
Saturday
time
on 6 p.m.
6
sir.
p.m. Saturday 6 p.m. and Sunday 10:30 a.m.
Sir, today evening also there, sir.
No, there is no class today evening. Yeah. So I think we have exceeded the time a little bit. So you can have this option of chatting with the instructor in the Practically app itself. So please make use of that facility. So until next week, we will sign off, and you can see some practice sets coming up after this lecture. So please have a look in. Yeah, I'll take
Sir?
this last question. Pranamya, you can go ahead.
Sir, if we miss this class, we can see in practical app, sir.
Yeah, so these lectures are also made available in YouTube Live, so you can have a look in. Have a look in
YouTube Live,
Sir,
sir.
what is the channel name?
You can check under the Practically channel.
Sir.
Yeah, I think I will mute you all since we have exceeded the time. So I would like to thank all the participants, and I would strongly urge you to take some of these puzzles and try to solve them in the week.
Yes, sir.
So try to do most of the problems on your mind. So thank you and namaste once again.